Hey guys, what's up? My name is Noah, and I'm going to be going over a theorem that we learned a few chapters back in geometry. And what this theorem, or I kind of made it up, and basically what I had said was that in a convex, in a standard regular polygon, like a regular convex polygon, if you want to be specific, I had said that the number of sides is equal to 360 divided by the measure of each exterior angle. And at that point, I didn't have time to prove it. But now I do, and I'm going to do so. Before I start, I want to establish a few things about one of those regular polygons. So we have a triangle here. Now we know that the number of sides is equal to the number of interior angles, right? So this is a triangle. We have four sides, and we have, or sorry, we have three sides and three interior angles. If we have a rectangle, we have four sides and four interior angles. Same with the pentagon, so on and so forth. We also have three exterior angles, I think. Actually, we might have a few more. But we're going to stick with the number of sides is equal to the number of interior angles, right? So, let's get started. We know that that 180 times n minus 2 is equal to the sum of the interior measures of all the interior angles, right? In addition to this, we know, all right, so that's the first step. The second step is distributing it, right? Distributive property, we can distribute the 180 across. So 180n minus 360 is equal to the sum of the interior angles. Okay, that's great. Now, what we need to know is what is the measure of each interior angle? Well, the measure of each interior angle is 180 minus the exterior angle. Why is that? Well, it's because if you come up here, let's say we have this interior angle, right? It's 180 because of the line, but it's subtracted by the measure of this exterior angle, and that's going to give you the measure of the interior angle, right? So 180n minus 360 is equal to 180 minus the measure of each exterior angle times the number of sides, right? So that's great. And the way that you can find the number of sides is this. This is what we're trying to show. How do you know what the number of sides are? Well, I'm going to go ahead and show you. So we have this equation now. Now we have to solve for this equation. You subtract the 100. Well, first you need to distribute this n, right? Put the n in front, distribute. We get 180n minus 360 is equal to 180n minus the exterior times n, right? That's what it's going to come down to. Now, we can cancel the 180n's because 180n minus 180n is 0. So negative 360 is equal to the negative exterior angle times the number of sides. If you divide the exterior angle, you get 360 divided by the exterior. Now, because both are negative, the negatives cancel out because a negative divided by a negative is positive. So you're going to get n is equal to 360 over the exterior. So that's a bit of a proof there for you guys. Going to check the time here. Oh, that's not that long. All right. Another thing is we were solving problems where we had a trapezoid. and we were trying to find the mid-segment. But we were given a measure for the mid-segment and one of the bases, and we wanted to find what the other one was. Now, don't hold me by this, but this is my thinking. If we have A resembling the mid-segment of this thing, and then, or not the mid-segment, if we have A as the mid line, right? And then we have x resembling one base and y resembling another, we have A is equal to 1/2 times x plus y. Now, if you distribute the 1/2, you're going to get A is equal to x over 2 plus y over 2. Now, if we carry y over 2, or even better, let's do this. If we subtract the x over the 2, okay, by each side, the whole thing, we're going to come out with A minus x over 2 is equal to y over 2, right? Now, from there, because we're going to have A and we're going to have x, but we're not going to have y, and that's my whole point. So now we're going to have to multiply both sides by 2. And basically, in order of operations, you do everything in the brackets first. So we're going to have 2, and in the brackets, we're going to multiply A minus x minus 2 is equal to y. I did an example, and it checked. And so this is the other equation that I came up with that you can use when you're trying to find the one missing, I suppose, base of the isosceles trapezoid instead of the mid-segment. I'm just going to call it the trapezoid mid-segment. Instead of that mid-segment is 2 times A minus x over 2. Of course, you do the x over 2 first, then you subtract that from A, and then you multiply that by 2, and you get the missing mid-segment, or the missing base, rather. So you have A, and then the x, and then you get the y. So I hope this helped, or at least you found it interesting or anything. So thanks for watching. Bye.